What was your educational philosophy during your tenure as Associate Dean for Academic Affairs?
My wife, I read that question, or I was talking about something like that with her, and she said, respect. You respected the students, you respected the faculty, you respected the need of the institution. That was the key thing. Maya had strong emphasis on quality of undergraduate education, because the graduate the dean's office doesn't have much to do with the graduate. That's all the department. But the undergrads, the College of Engineering has quite a bit of control over, and we tried to not have rules that were silly. We tried to take care of them, make them work very, very hard, but respect that work. And
were there any programmatic changes or new initiatives that you began which have had long-term impact on the type of education students now receive?
yes, we put together a writing program for the engineers, and it was a wonderful success. And engineers have a tendency to want to get everything right when they first put it down on a piece of paper, and you just can't do that. You get the ideas down, get the right ideas down. Don't even worry about the order. Just get them down and then cut and paste. And I learned that in industry when I could use a dictaphone, had access to a dictaphone, and I would dictate for about 3 or 4 hours, and it would turn into a pretty good piece of work after you turned all the things right and corrected the things that you'd gotten wrong and put it in the right order and all. Now you can do that with word processing. It's a piece of cake, but it wasn't then.
Over the years, you have sponsored many students in internships and industry causes. Do you see benefits to the students who began a connection with local companies during their undergraduate careers?
Oh yes, they learned a great deal just by doing it. The hands-on, it gives them confidence. It makes real what before has been on paper. And many of the students would stay, and sometimes they would do something in the summer, and then they would work part-time during the school year at good salary. I mean, not graduate engineer salary, but not broom sweeping, not minimum wage at all. They were very valuable to the companies, and it was very valuable to the students.
ECE S2A Digital Lab was one of the classes you taught on a regular basis.
Yeah, 152A. That's what it is. 152A, yeah. That was a class with a lab, and Jim Howard, who died a number of years ago, was the man that developed it, although he and I worked together for a number of years in what we should do to modify the class. What it is a beginning class in digital hardware design, and it has a wonderful lab. That was the thing that distinguished it. Everybody teaches the material, but if you don't really build things, it's not quite the same. And we decided very quickly that what we were going to do was interface. We had to worry about interfacing a piece of hardware. We'd give them a problem and say, solve this any way you want, but part of it has to be on the superstrip board in hardware, and part of it has to be in the computer in software. And you can decide how much to put each side, and groups would do it very, very differently. And that class was required of all computer science students and taken by almost all electrical engineering. It's required of ECE students now. That wasn't, when it was just EE and CS. Still, maybe 85% of the EE undergrads took the class. It was a very, very popular class. It was very useful.
So that class is a key component for EE majors in completing degrees?
Oh yes. Yeah, as I say, it was, almost everybody took it, even if they were going in a different direction. Even if they were microwave, many of them would come over and do that class just because they wanted to understand the hardware that they were going to be using, and everything was going to digital.
And what was the first computer you ever used for that?
For that class? I think the first computer we ever used for that class was, what was it? My goodness. I think it was a Data General. It was a time-shared computer. We used that, and then one of Jim Howard's graduate students did something he called ACIP, which was a simple integrated computer, or some interactive computer or something. A little tiny blue box based on the 8008, which was Intel's chip before the 8080, which was what was in the ATs and the IBM microcomputers. And so we had that we did the time shared system for a while, and then we did the ASIC, and then we used 8080, the bench computers were 8080 computers. And I don't know what they're doing now. They may be doing 68,000. I'm not sure. We had a class where we used 68,000, but I don't know. I haven't done that for a number of years now.
Given your successful career as an engineering professor, would you recommend students to become professors?
It depends on the student. You don't do it to make lots of money. I took a 60% pay cut to come from industry to UCSB. Now, admittedly, I was coming as an assistant professor. I was coming at the bottom of the scale for professor. And I was not at top scale, but I was at pretty close to the top of the working stiffs. I was not making the high management level, but I had a group of 10 or 12, 7 to 12, depending on what we were doing, people that reported to me. But I had taught as a master's student, had my own class and taught, and I really got hooked with it. And I did a couple of night classes when I was in San Diego, and liked it even more. And so I just decided that let's try it. And people don't believe it now, but I said, well, Santa Barbara was a cheaper housing market than where we were in Los Angeles. We were living in the low rent district of Pacific Palisades. We'd bought a house for $25,000 when I'd moved there in '59, and we sold it for $32,900 in a very depressed market, and came up here and for $35,000. This was a 1,220 square foot house that we had in the Palisades, and we came up here and bought a house with another 1,000 feet for $35,000. So it was a good time to come.